Hello and welcome back. Today we'll be doing question 1 from the 2009 Step Paper 2. This is a question about symmetry. So let's get started. Two curves have equations x to the 4 plus y to the 4 equals u and xy equals v, where u and v are positive constants. State the equations of the lines of symmetry of each curve. The curves intersect at the distinct points A, B, C, and D, taken anticlockwise from A. The coordinates of A are alpha, beta, where alpha is greater than beta is greater than 0. Write down, in terms of alpha and beta, the coordinates of B, C, and D. Show that the quadrilateral ABCD is a rectangle and find its area in terms of u and v only. Verify that, for the case u equals 81 and v equals 4, the area is 14. Pause the video to have a think, and once you're ready, restart to see if you were correct. So, let's get started with the first part of the question. Firstly, we'll just be listing all of the lines of symmetry of our two curves. Both curves have lines of symmetry in y equals plus minus x, but x to the 4 plus y to the 4 equals u also has lines of symmetry in the x and y axes. The common lines of symmetry for the two curves are y equals plus minus x. Therefore, by symmetry, we have the following four coordinates. A has coordinates alpha beta, which is given. B has coordinates beta alpha. C has coordinates negative alpha, negative beta. And D has coordinates negative beta, negative alpha. Here, I've listed all the sufficient conditions for a shape being a rectangle. Here, we have AB equals CD and BC equals AD. That is, opposite pairs of sides are equal in length. These two conditions make the shape a parallelogram, and now we only need one 90-degree angle in our parallelogram to show that our shape is a rectangle. Now we need to prove these three statements in turn. Firstly, I'll prove that AB is equal to CD. Here we have a calculation for the length of AB using Pythagoras' theorem, and this simplifies down to alpha minus beta of root 2. Similarly, an identical calculation for CD simplifies down to the square root of 2 alpha squared minus 2 beta squared plus 2 alpha beta, which is an intermediate step in the simplification of AB, and therefore CD is equal to AB as required. Using a similar method, we can say that BC is equal to AD, and these two are both equal to alpha plus beta of root 2. Now, we need to find the gradient of AB and BC. The gradient of AB, which I will call M1, is beta minus alpha over alpha minus beta. And the gradient of BC, which I shall call M2, is alpha plus beta over beta plus alpha. Multiplying these, we get beta squared minus alpha squared over alpha squared minus beta squared, which is equal to negative 1, and therefore AB and BC are perpendicular, as required. Therefore, we have that ABCD is a rectangle, as required. We now need to find the area of this rectangle. Seeing as it's a rectangle, we can just multiply the perpendicular sides together, and this gives 2 of alpha squared minus beta squared. We need to write this, however, in terms of u and v, and we can see that squaring alpha squared minus beta squared is equal to alpha to the 4 plus beta to the 4 minus 2 alpha squared beta squared, which is equal to u minus 2v squared, so that our area is equal to 2 of the square root of u minus 2v squared. Now, when u is equal to 81 and v is equal to 4, the area is equal to 14, as required. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.